So we're in section 5.3. We're going to solve trig equations. So trigonometric equations come up whenever or often when we have some kind of thing that's periodic, something, for example, that's rotating, something that is moving up and down regularly. So we can describe its behavior, its motion with trig equations. And what we want to do is be able to work with those trig equations, find solutions to the trig equations, find intercepts, all the things that we've done with solving equations in the past, but involving trig equations. Couple of things that make trig equations different is that trig functions are periodic, so we get multiple solutions, and then they behave a little differently than some of the equations that we worked with before. So our big picture rules here are that, and this is not 100% true, just kind of a main guideline, is we want to get a trig function by itself, or trig functions by themselves on one side of the equation. And the other thing that we have to remember is we want to solve for or find all solutions. And by all solutions, what we're remembering is that when we go around our unit circle another time, we get to a coterminal angle, and we get another angle that's going to give us a solution. We're going to find all solutions. We're going to apply all of the techniques that we know about solving algebraic equations. We're going to use factoring. We're going to use simplifying. We're going to use substituting. We're going to combine like terms. And because we're dealing with trig functions, we're also going to use trig identities sometimes to simplify our equations before we solve them. So what I want to do today is similar to what we did the last couple of days. I'm just going to go through some examples of different types of trig equations and how we solve them. And we should have, at the end, we should have plenty of time to work on the homework so that you can ask questions. So we'll start off with an easy one. We want to solve, and all of these examples today we're going to solve, 1 minus 2 cosine theta equals 0. So there's our equation. So our basic guideline, we're going to get the trig function on one side and everything else on the other side. So I add 2 cosine theta to both sides of the equation. So I get 1 equals 2 cosine theta. I'm just going to turn it around and write it the other way. 2 cosine theta equals 1. Want the trig function by itself, so I divide by 2. So cosine theta equals 1/2. Now this is a unit circle problem. We've gone from solving a trig equation to a unit circle problem. Yes? The ones that we do are normally going to be unit circle problem. If not, in just a second I'll talk about how we would deal with it otherwise. So then we say where on the unit circle is cosine equal to 1/2. So we say theta equals. So where do we get a cosine of 1/2? Pi over 3. And we want all of our solutions. So if we go around the circle again, we get another solution. The way we write that is plus 2n pi. And n is just an integer. So n can be 1, 2, 3, negative 1, negative 2, negative 3, or 0. So that's just taking us around the unit circle again. So we can go around as many times as we want and stop at that place and still get a solution. But we get another answer. Where else is the cosine 1/2? Let's draw our circle. Here we are at pi over 3. Cosine, the x-coordinate is positive 1/2. So what other angle gives us a positive 1/2 for our cosine? So it's going to be 2 pi over 3. That would give us a negative 1/2, right? So 5 pi over down here. And we say plus 2n pi. And I could also, it would not be incorrect to call this negative pi over 3. You could say positive pi over 3 and negative pi over 3. That would be fine as well. So this gives us all of our solutions. And graphically, just looking at what a picture of this looks like, if I sketch out a rough graph of my cosine function, and we've done some homework problems in the past, like this, where they say find the solutions to this equation using your calculator. So what we're doing is graphing the cosine function, and then we're graphing the line y equals 1/2. So there's a line y equals 1/2, and we're finding all of these places where they intersect. And we can keep going and keep going and keep going, and that's what this 2n pi does for us. So this would be pi over 3. This would be pi over 3 plus 2 pi. This would be 5 pi over 3, 5 pi over 3 plus 2 pi. So that would get us all of our solutions. So if we had a problem where we got some answer that wasn't a unit circle, a familiar unit circle angle. So for example, say we got cosine theta equals, I don't know, 0.684. We could graph cosine theta, and we could graph the line y equals 0.684 on our calculator and find those intersections. And there's a couple of problems in your homework where it asks you to estimate or approximate the solutions using your calculator. So that's what you do. You graph your functions and find those places where they intersect. So this is what we're looking at if we're looking at a picture of these solutions. All right, questions on that example? So on the quiz tomorrow, this would be an example of the type of equation I would ask you to solve, where you end up with something not a lot of manipulation, and you end up with something like cosine. Where is cosine theta equal to 1/2? All right, let's look at another example. We want to find where tangent cubed x minus 3 equals 0. We want to solve that equation. Do I want tangent? No, I want tangent squared. Sorry. Tangent squared x equals tangent squared x minus 3 equals 0. Get my trig function by itself. Tangent squared x equals 3. Now how do I go about finding the solution? Take a square root. So I get tangent x equals, and I'm going to write square root of 3. But when we're solving equations, we take a square root. What do we have to do? Plus and minus. Very nice. Plus or minus the square root of 3. So now we've turned it into a unit circle problem. Where on the unit circle is tangent of our angle equal to square root of 3? So I'm going to say x equals, and the plus and minus gives us multiple solutions. So on the unit circle, where do we get a tangent of square root of 3? Tangent is sine over cosine. So we have to have our square root of 3 in the numerator to get a square root of 3. So our y component has to be the larger one. So what is it? Pi over 3. And what is the period of tangent? pi. So we add n pi for tangent. The period of tangent and cotangent is pi, so these repeat every pi units. What other angle gives us the tangent of positive square root of 3? So we're here on our unit circle. There our tangent is positive square root of 3. Both sine and cosine are positive. 4 pi over 3 down here. So x equals 4 pi over 3 plus n pi. So those are our two positive square roots of 3. How about the negative square roots of 3? So then we'd be here and here, right? Where our sine and cosine have different signs. So what are those angles? 2 pi over 3 plus n pi, and x equals 7 pi over 3 plus n pi. So we end up with 4 answers here. But let's take a closer look. If you wrote this down, this is not incorrect. So what I'm saying is, what we're going to do next, I'm not saying this is incorrect. This is fine. But let's just take a closer look. What's pi over 3 plus pi? How many pi thirds is pi? How many pi thirds is pi? 3. So pi over 3 plus 3 pi over 3 is 4 pi over 3. That takes care of this one. So these two really are the same. 2 pi over 3 plus 2 pi over 3 plus, this should be 5 pi over 3, right? 7 pi over 3 takes us back up here. So this should be 5 pi over 3. 2 pi over 3 plus pi over 3 is, plus 3 pi over 3 is 5 pi over 3. So those two are the same. So we would be fine if we just wrote those two answers, because these lead us to these. It would not be incorrect to write all 4 of them, but these two give us these two. I would not take points off if you wrote all 4, because these are solutions. They are correct solutions. And then graphically, what we're looking at here, if I sketch a quick graph of my tangent function repeats like so. I know my graph isn't beautiful. And we're looking for plus or minus square root of 3. So our line goes through like so, and like so. So we're looking for all of these points of intersection. Yes? No. I'm just trying to give you just kind of another way of thinking about what we're doing. It helps me if I can visualize things. So I just want to give you another tool to think about these things. So this is where it equals positive square root of 3, negative square root of 3. Our period is pi, so this repeats every pi unit. That's what we're looking at, just kind of a rough picture of what we're looking at. And making these little sketches, I find them helpful. If I'm having a hard time thinking about it, just making a little sketch of a circle to help me with what I'm thinking about. All right, questions on that example? Okay. Let's make it just a touch more complicated. Let's say we have secant theta, cosecant theta equals cosecant theta. And we want to solve this. So because we have these two trig functions, we have them kind of mixed together. We're not going to have one trig function on one side of the equation. We want to get all of them on one side of the equation. So what would we do to solve this? What do you think? Okay, we could divide by cosecant. Well, let's think about. Let me write this. What if we had xy equals x, and we wanted to solve that? What is it? We want to subtract x. If we divide by x, what are we assuming? That x does not equal. What can't we divide by? 0. If we divide by x, we're saying x is not 0. It could turn out that x equals 0, and then we'd have a problem. So we subtract x from both sides. So we would do xy minus x equals 0. We're going to do the same thing here. So I get secant theta, cosecant theta minus cosecant theta equals 0. Now what can we do? Pull out the, here we pull out the x's, here we pull out the cosecants. So I'm going to factor out that cosecant theta. So cosecant theta times secant theta minus 1 equals 0, after I factor out that cosecant theta. Now what does this problem tell us? I have two things that are multiplied together that equals 0. So how do we solve an equation like that? One or the other, right, has to equal 0. So I say cosecant theta equals 0, or secant theta minus 1 equals 0. So I get two possibilities. If I'm multiplying two things together to get 0, one or the other has to be 0. Same thing that we would do here. If I pulled this out, y minus 1 equals 0, we would say x equals 0 or y minus 1 equals 0. All right, so cosecant theta equals 0. So we need to solve that equation now. Cosecant is related to which trig function? Sine. So this says 1 over sine theta equals 0. What angle would let 1 over sine theta equal 0? We can't divide to get 0, right? The only way this fraction equals 0 is if the numerator is 0. So this gives us a no solution. We can't get 0 from this fraction because the numerator would have to equal 0. So now let's look at this one. This tells us that secant theta equals 1. Secant is related to cosine. So this says 1 over cosine theta equals 1. So what does that tell us the cosine of theta has to equal? Cosine theta equals 1. That's the only way this fraction would equal. Now on the unit circle, where is the cosine of the angle equal to 1? 0. And I'm just going to say 0 plus 2n pi. That takes care of the 2 pi. And I could leave off the 0 if I wanted. So we can write 0 plus 2n pi or just 2n pi. So any multiple of 2 pi gives me a cosine of 1. So this would be my solution. So we started with one equation, ended up with two equations. One of them didn't give us a solution. The other one did. Question?
Will there be anything on the quiz that doesn't solution?
No. Yeah, the problems I give you, they turn into unit circle problems. All right, so let's look at another type of equation. So sometimes we have to factor this way to find our solution. We have multiple trig functions we have to factor. So let's look at another kind of equation where I have to factor. So quadratic equations. So for this example, we have 2 cosine squared x minus cosine x minus 1 equals 0. And we want to solve this. Well, we've simplified some trig expressions like this. What did we do to simplify expressions like this? Do you remember? Now this one isn't like the last one. We can't pull a common factor out because we have this 1 here. So let me write something else down. Hopefully this will jog our memories. we have to factor. This is just like the equation 2x squared minus x minus 1 equals 0. But instead of x, we have a cosine. We have a cosine squared, a cosine, and a number. So I'm going to factor this. So I'm going to end up with 2 parentheses equals 0. So how is this going to factor? Well, let's think about this one. This one is going to have to be a 2x and an x to get a 2x squared, right? And a 1 and a 1 to get that 1. And how do my signs need to work here? Minus and a plus. Going to get us where we need to be. This one factors exactly the same way. 2 cosine x plus 1 times cosine x minus 1. Exact same process, exact same thought process here. And now we're back to where we were on the last problem. 2 things multiplied together giving us 0. So that means that this parentheses tells us that cosine x equals negative 1/2, or cosine x equals 1. Setting each of these parentheses equal to 0. Now did we factor this correctly? Yeah, I think we did. So on the unit circle, where is cosine equal to 1/2 or negative 1/2? So we want our x coordinate to be the short side of our triangle and negative. 2 pi over 3. Two pi over 3 plus 2n pi, and where else? Gives us a negative x coordinate of 1/2. 4 pi over 3. And this says cosine x equals 1. So on the unit circle, when is cosine equal to 1? Zero. That would give us a negative 1. So those are our solutions. 2 pi over 3 and 4 pi over 3. Or 2n pi. And we factor this equation just like we factor this. Questions there? Now sometimes they'll ask the question, they'll say find the solutions in the interval 0 to 2 pi. And what they mean by that is you don't have to go around the circle again. So you just, if the problem asks you find the solutions in the interval 0 to 2 pi, it's just asking in one time around the circle, where are your solutions? So here it would be x equals 0, x equals 2 pi over 3, 4 pi over 3. That would be the solutions in the interval 0 to 2 pi. So we're not going around again, so you don't have to worry about these things. All right, let's look at another one of these. 2 cosine squared x plus 3 sine x minus 1 equals 0. And we want to solve that. So what's our problem here? We have a cosine and a sine. And it's not like the one we did with the cosecant and the secant, where we can just factor one out, because we have this 1 here. We don't have multiple trig functions here. So what do? We can change this cosine squared to a sine squared using our Pythagorean identity. So I know that we have this nice relationship that relates cosine squared and sine squared. So I'm going to write this as 2 times 1 minus sine squared x using our Pythagorean identity, plus 3 sine x minus 1 equals 0. Now I distribute. I get 2 minus 2 sine squared x plus 3 sine x minus 1 equals 0. Then I can rearrange this and write this as negative 2 sine squared x plus 3 sine x minus, and let's see, what did I do here? I think I wrote my, I wanted this to be a 3. So I wanted that to be a minus 1. There we go. And that equals 0. I knew there was a minus 1 in there somewhere. Alright, so we want to solve this. I would prefer not to deal with this negative 1 in front, so what can I do with that? How can I get rid of that negative 1? What's that? Multiply everything by negative 1. I have a 0 on this side, so it's not going to change anything. So I can write this as 2 sine squared x minus 3 sine x plus 1 equals 0. And now I want to factor this. So I know I'm going to have a 1 and a 1 here to get my 1s. I'm going to have a 2 sine x and a sine x to get my 2 sine squared x. Now I just have to figure out my signs. In order to get a positive 1 here and a negative 3, I'm going to have to have a negative and a negative. Now I have my 2 parentheses. This equals 0. And now I'm almost done. This parenthesis tells me that sine x equals 1/2. And this one tells me that sine x equals 1. So now I look on the unit circle. Where do we get a sine of 1/2? Didn't we already do this one? Where do we get y coordinate of 1/2? Pi over 6. Or where else do we get a pi over a y component of positive 1/2? Pi. That would give us a negative 1/2 for the y component, so 5 pi over 6. They're 180 degrees around. So x equals 5 pi over 6 would give us a positive y component of 1/2 plus 2n pi. And where is the sine equal to 1? Sine of our angle equal to 1? Pi over 2. So we end up with 3 solutions here. Pi over 6, 5 pi over 6, and pi over 2. All right, questions on that example? So we've talked about the basic kinds of equations where we just have to get everything on one side. One type of equation where we have to factor. These quadratic types where we have to factor. This one we had to use an identity to get us started. One last kind of equation that I need to tell you guys about. Sometimes we'll have equations that involve a multiple angle or a half angle or something like that. So if we had, for example, 2 sine 2 theta plus 1 equals 0. So we have this 2 theta now. We proceed to go about it just the same way that we've done before. So I'm going to get everything on my trig function on one side and everything else on the other. So I get sine 2 theta equals negative 1/2. Well, now when I'm looking on my unit circle, I'm finding what 2 theta equals. So on the unit circle, where do I get a sine of negative 1/2? You found one for the last one, right, Marcus? 11 pi over 6 plus 2n pi. But we want theta, not 2 theta. So we divide everything by 2. Theta equals 11 pi over 12 plus, when I divide this by 2, n pi. And I get one more angle. 2 theta equals, what's the other angle with a sine of negative 1/2? 7 pi over 6. So theta would equal 7 pi over 12, and this should be a 2n pi plus n pi. And we can think about this n pi. We're adding multiples of pi. What's the period of sine 2 theta? Pi. 2 pi over b, 2 pi over 2. The period is pi. So this is adding one period for sine 2 theta. So when you have a multiple angle or a fraction angle, you solve for the multiple angle or the fraction angle, and then you deal with whatever the number is here in front of theta by multiplying it or dividing it, depending on whether it's a fraction or a whole number, to the other side. And it multiplies everything over here. All right, questions on these? Okay. Homework? We got plenty of time to work. If you have questions, it's a great time to ask questions. Make sure you're understanding all of this. There you go.